Good morning. Welcome to the presentation on automated testing JavaScript. My name is Venkat Subramaniam. I'm going to talk a little bit about why we should really focus on automated testing, a little bit about the benefits we derive out of it, and then we'll dive in and look at automated testing of JavaScript. This is a concept that I'm absolutely passionate about. Well, a lot of times I work with a lot of different companies. I consult and train and mentor. And when I go to organizations, they often talk about how they are agile. And one of the first things I tell them is, I'm so glad we can get that out of the way. Now let's talk about what you actually do. So I really like to focus on what I like to call as sustainable agile development. So if agile development is all about being able to respond to change, how can we really respond to change over time? Well, there are several things we do in agile development, but one of them is adaptive planning. But more important, it is really, to me, agile development is feedback-driven development. So if feedback is extremely important, we get feedback in two different ways. One is the feedback from our customers that the code is actually relevant and does what they really want it to do. The other feedback is that the code actually works and continues to work. Now, as programmers, we often are faced with continuous change of software. Well, software is a non-linear system. You could change something over here and something completely at a different place falls apart, and then we spend our time trying to figure out and debug. And the most embarrassing thing for us, not only in terms of reputation, but also economically, is when we make changes to software, but things don't really get back to shape and work, and we end up fixing bugs over and over. It can become really, really hard. I once tweeted that programming is the best job on earth, because my definition of a programmer is somebody who gets paid once to do the work and gets paid repeatedly to do it again and again and again. So we never want to let the management know about this, right? Because we have the best job because we can get paid for doing the same thing multiple times. But I think we should really have the professional responsibility to fix that and get a better feedback loop. Now, when it comes to software, in an agile development environment, we constantly change and evolve to change and respond to change. But one of the things we often are faced with is, as a programmer, you sit there and make change to the code. You change code because you want to maybe fix a bug, you want to make an enhancement, add a new feature, whatever that may be. And when you're done, you say, I've finished that work. And then they ask us this most dreadful question nobody likes to get asked, isn't it? They ask us, does it work? And oftentimes, programmers have this beautiful sentiment they represent. They call it, I hope. And I love this phrase, I hope, because we hear this constantly. In fact, it is so popular, there's a technical name for it. That approach of developing software is called JDD, which stands for Jesus-driven development. And we do this a lot in our development. And don't get me wrong, I do put faith in the Lord, but I think the Lord has better things to do than worry about the stinking code I'm writing. I would rather do TDD rather than doing JDD. And again, I want to emphasize what TDD is, because in some organizations that stands for threat-driven development. No, I want to talk about test-driven development over here. So how do we really approach our testing to get that feedback loop so we know the code is actually working? And I want to start by quickly saying, I love manual testing. And I want to just put that out and say, I do really love manual testing. I know you're looking at me with the suspicious eyes and like, are you crazy? Well, I want to emphasize that because I want to define what testing really means to me. So testing is an act of gaining really insight into the application. That's what testing really is for me. It's an act of gaining insight. Hey, should we really eliminate this workflow that we are doing at this point? Maybe we should really restructure our application. Maybe these forms are really not laid out properly. Hey, is the performance really good? Are there things we can eliminate from the application that the user is not burdened with? To me, those are testing. But on the other hand, what do we do most of the time when we write code? We want to know the simple fact. It worked yesterday, and then we ask the question, yesterday, does it still work? This is one of the things we really want to know, is that it worked yesterday, does it still work? That's not testing to me. I want to say that is called verification. And I want to emphasize that when it comes to verification, we should never verify manually. So automate, I would say, your verifications. So in other words, we want to be able to get a very rapid feedback that the code we wrote yesterday still works today. And manually verifying software is the most insane practice in our industry. And I would even argue asking a human being to verify if the code still works is an insult on humanity, and we should never tolerate that. So the point really is we should write the test once and automate it so we can get a continuous feedback loop, and that is extremely important. And once we get into our culture, we can do that really, really well in our applications. But unfortunately, though, the problem is that when it comes to automated verification, how do we really do this? Well, part of the reason is that we want to get really good at it. And in my experience, I've seen three kinds of organizations out there that are really attempting to work in this particular area. The first one I've noticed, unfortunately, is the industry-wide standard is no automation at all. So these organizations do still manual verification. They verify the software, they write the code, and then they put a group of people to really click on the buttons and see if things really work. Unfortunately, this doesn't scale because as the software becomes bigger and bigger, when you make a change to a piece of code, you cannot just isolate and test that alone. You need to make sure that the entire application is still working, and there's no way you can keep up with the pace. And these organizations are losing big time, but they're just in denial in terms of how they can approach it. But to me, one of the biggest concerns I have is not just the fact that these organizations don't spend enough effort automating. There is a generation of programmers that work in these organizations who totally lack the skill to automate, even when that is becoming essential to what they do. So imagine working in one of these organizations and then going into another company where automation is being done. You start at a very significant disadvantage because you simply don't have the skill to really do it. And that's one of the biggest concerns I have is I want to be able to automate and deliver better product and results. So that skill is important as much as the results we produce as well. The second group of organizations is yes to automation, but well, these organizations have realized that automation is extremely important, but they are still struggling to figure out how to actually do it. And one of the things they do is to go hire people with a really beautiful title. For example, an automation engineer. Well, the automation engineer gets hired, shows up to work one morning and says, hey folks, I'm the new hire, I'm the automation engineer, I'm here to work with you all. The programmers who are busy fixing bugs look at the new hire and say, hey, welcome to our company, now don't bother us, go away. And so the poor automation engineer walks around and figures out what he or she can do. And as time goes on, a few weeks goes by, the boss runs into the automation engineer in the lobby and says, hey, you've been here for a few weeks now. Friday at 2 p.m., I want to talk about what you have done so far. And the automation engineer is like, oh my goodness, what do I do? The programmers don't want to talk to me. They don't want to help me to automate, but I got to automate this application. What can I do? And this automation engineer discovers this beautiful thing called Selenium. Now, this is amazing because Selenium actually is, in my observation, leads to one thing called a pathway to hell automation. And this is basically one of the problems is because every single organization I've come across has landed into this trap, and they don't have the ability to maintain the test in the long run, and it becomes really, really hard to keep up with. And I'm of a firm belief that automation should be done at the right level to the right measure. So that's exactly where I want to be. But at the right level, and I'm going to say to the right measure. So in other words, how do you really get to the right level and the right measure for automation? Well, we live in a field where we'll do weird things, but give beautiful name for what we do. This kind of approach where most of the automation is done at the UI level is often called as ice cream cone pattern. And this ice cream cone pattern actually is an anti-pattern rather than being a pattern, and this becomes really hard to maintain the automation in the long run. But what we really want to achieve is what is called a test pyramid. And the test pyramid gives us an ability for us to write the automation at the right level to the right measure. And so, in other words, how do we really do automation? My argument is, don't write most of your automation at the UI level, but peel off the UI just a little bit and then do the automation one layer below that. And when you're developing the front-end application, sure, you want to be able to run your automation on the JavaScript, but you want to be able to run that not through the HTML layer, but one right below. But of course, you may ask, well, why are we running the code at the JavaScript layer? I'll give you an example of this. I was working on an application where I need to pull, as an example, let's say, employees that work in an organization. But the problem is that I need to be able to sort these employees based on their names, and if the names are similar, based on other criteria. Now, how do I know my code is not only displaying the employees properly, but in the sorted order as well? And I sat down to write this test at the UI level, and I realized how verbose and tiring this was. And I realized quickly, why am I even bothering doing this at the UI level? After all, if I'm going to be putting that code in the HTML, that's probably a sign of really bad design in the first place. And that is one of the things I want to emphasize quite a bit. I often listen keenly to what programmers say. When you hear a programmer say, this code is hard to test, now what they really mean is not that this code is hard to test. What they really mean is the design of this code sucks. That's what they really mean. So normally when people are complaining about testability, they're really complaining about the poor design in the code in effect. So, and I realized that I was really, barking at the wrong tree at this point. So what I did was I wrote a test at the JavaScript layer where the sorting was actually happening. And that was much faster, much easier, a really quick feedback loop as well. And I don't have to waste my time writing the code at the HTML level. I can write the test at the JavaScript level. Now, I'm not going to tell you that we should never do any testing at the UI level. What I'm saying is that most of what we do should be layers below. In other words, I'm going to say integration testing, to use a metaphor, is like salt in a meal. Now, we all can agree, we can't have a meal without salt, but we can't and we shouldn't really make a meal, off salt as well. So this is exactly my point about integration testing. Integration testing is like a salt in a meal. You want enough of it, but not all of it. So I would definitely want to have integration testing just to tell me there's life here, that there's a connectivity between my HTML and the JavaScript below, the buttons are wired properly, and I'm done with the testing at that layer, and I would drive my test in layers below after that quite a bit. Well, enough talking about these stuff. Let's take a look at how we could do some of this. I'm going to use absolutely trivial examples over here. And the reason is that I don't want to get dragged into a problem, but I want to focus on the tools and the solution and the approach I would take. If you're interested in this, there are so many different tools out there. I don't want to emphasize the tools I'm going to use here are really not the recommendations in any stretch of imagination. They're just examples. Use whatever tool you want to do or you want to use. Almost every single tool out there is good enough to solve your problems. The most important thing is, of course, to have the discipline and the commitment to really do this. And once we have the driving force of discipline and commitment, we can figure out how to use any of these tools. So let's get started with a little example and see how we can use it. And then, of course, what I'm going to show you here works pretty much with back-end JavaScript and also front-end JavaScript as well. I typically give this talk over 90 minutes. I spend half the time on a back-end JavaScript, and then I switch over to front-end. But given the time limitations we have here, I'll just focus on the front-end alone and show you some examples of how we can actually do this. So let's start with a little quick example of setting up a project that we can use to begin with. So here I have an empty directory. I have nothing really here. I'm going to just go ahead and create a directory here. Let's call it as sample for lack of better words. And I'm going to simply do an npm init on this just to go ahead and get started. I'm just going to take all the defaults right there. So all that it created was a package.json file, as you can see. So now that we have a package.json file, let's get started with that as a starting point. Let me just open up this package.json file in the sample directory. So what do we notice in this particular file? Well, it doesn't have a whole lot right now. As you can see in here, that is just a regular plain package JSON, nothing really exciting. But I'm going to install a certain tools we need before we get going, and I'm going to do an npm install. I'm a huge fan of Mocha and Chai. I've also used Jasmine. Like I mentioned, it doesn't matter what tools you choose to use whatever tools you want to use. So I'm going to start with Mocha and Chai and a bunch of other dependencies. We'll talk about what those things are when we walk through them, not all at the same time. So what I want to do here is simply do a npm install of all those things, and then we will move on really quickly after that. So now that I'm installing those things, what am I going to do? I want to start writing an automated test, and I'm a huge fan of really fast feedback loops. And I often start writing tests on a new project by writing what's called a canary test. A canary test is the stupidest test you can actually write. A canary test simply asserts that true is true. Now you may wonder, why bother writing such a stupid test? A case in point, I was at a client site where I knew nothing about their project, but my job was to help them to get better at automated testing. So I sit down next to this programmer who says, hey, we know you're coming, we're all ready. And I said, well, let's write a canary test. He said, what is that? I said, assert true is true. He said, well, that's stupid. I said, absolutely true. Oh, so it shouldn't take a whole lot of time to do stupid things, isn't it? Let's get that working. I'm not kidding. It took us 40 minutes to get the canary test to pass because the tools were not set up properly, environment was not configured properly. And what do I know as an external person about their proxy settings? So it took us a while. And when somebody comes over to say, what are you doing? Let me help you. If they look at 40 lines of code you have written, they're going to argue about that code. But when you show them a stupid, assert true is true, they're going to say, that's stupid. It's like, yeah, let's get that working. So it can give you focus on the tools. Also, when you come to a project, if things are not working because you upgraded something, well, you can quickly see if the canary test is passing. If that doesn't pass, why bother looking at anything else? So a canary test is very useful to get that really quick feedback loop. And this goes to the concept of canary in a coal mine, where the miners take this bird canary to the mine. This is really good for the miners, but not so much for the canary, but to get a quick feedback that something is wrong and they can escape out. Well, all I did was I installed Mocha and Chai right now, but I also installed Karma. And Karma is a tool that is useful to run your test within a browser, and so we can make use of it. So what am I going to do at this point? Well, I'm going to do a couple of different setups. The first thing I'm going to do is to go to the node modules directory right here. In fact, I'll do this from here. So I'll go to the node modules directory, go to Karma, and I'm going to run, in this case, the Karma tool with the init, so I can just initialize this really quickly. It's asking, do you want to use Jasmine, or what do you want to use? Pick up the tool you are interested in using. I'm just going to use Mocha for now. It says, do you want to set up a require.js? I said no. It says, do you want to use Chrome? You can say absolutely if you want to use Chrome. You can also tab and use other versions of the browser, so you can have your code tested across browsers as well. So pick whatever that you like to choose. Heck no. But anyway, so choose whatever that you like to use, but you can decide on the particular browser that makes sense. You can even run multiple browsers if you're really interested. And at this point, I'm just going to hit the return and take the defaults, and that brings us to karma.conf.js. Let's take a quick look at it. I'm going to configure a few things in here. I'm going to bring in addition to Mocha, I'm going to bring in Chai as well, because Mocha is the testing tool. Chai gives us the assertion library that we can actually use. So I'm going to bring both of those in here. We'll come back and add a few more things later on. What are the files? Where are the files I want to use? I'm going to say the first thing I want to use here is test. And within the test, I want to go to all the subdirectories and open up all the JavaScript files. And I'm going to also use a source directory and bring in all the JavaScript files as well. So I provide the path to where my files are located, or they will be located. And that's all I have so far, and I'm going to come back and look at a few more things. But really quickly, an auto watch is really useful to keep running the test as you are working with the code, so you don't have to keep running the tool over and over. In the browsers area, you can see Chrome, but you can put other browsers here as well, as much as you would like to see those tests run across. So we'll come back to this file later when we need it. So we installed a bunch of stuff. So what do I want to do next? Well, the next thing I'm going to do is, for the test, I'm going to start Karma right here, and I'm going to run essentially Karma, and I'm going to say start, and the reporters I want to use is the dots reporter that puts a little dot as the test is running. For impatient people like me, I know that things are still running. And one of the things that really made me angry working with Karma in the beginning was it would run the test, and then you make a code change, it runs test again after that. And that was annoying for me because if I want to look at a failure, I was not sure which run the failure was part of. And I spent a few minutes looking for a little plugin, and I was so happy to find Clear Screen. So every time you save a file, it clears your screen and then runs your test, so you only see the latest output on your screen. So that's a lot easier to just keep your focus on and look at only things you need to really look at. All right, so with that said, let's get to the first test, which is the canary test, to get the feedback loop going. So what am I going to do here? Notice that in this case, we have the package JSON we created. We got the karma-conf.js. Let's create a directory called source and a directory called test as well. Within the test directory, I'm going to simply create sample test.js. That's just a test file we're going to start with. So what am I going to do in this test, first of all? Well, in this test, what I'm going to do is to start with the describe, and this is going to be describing the test I want to start creating. So the describe, I'll call this a sample test to begin with, and I'm going to create a test called the canary should sing, or whatever you want to say. So basically, you can write a canary test expect. Well, this is going to be using the chai API. You can use expect, you can use assert, you can use should, whatever that makes you happy. I have no personal preference at all for the word to use. They can use whatever they like to use. So expect true to be true. That's my stupid canary test to begin with. And I want to know that's working before I do anything else. So what am I going to do right now? So I'm going to run npm test right there, and I want to get the feedback. You can see it opens the browser, runs your test within the browser, so the JavaScript has a home to execute. If you're running on the node and the server, obviously you don't need Karma. You can write the code and run it on node, but in this case, I want to know it's working properly across the browsers I'm using. Typically, I would just close that away, get it out of my sight, and you can see that it says success right there. That tells us that that one test that it ran, you can see that little dot in there that executed and it passed. But of course, one of the key things is when you do TDD, never to take a passing test as a glorified signal that everything is cool. I remember this embarrassing moment working with a developer. We were writing test and writing code, writing test, writing code. About the fifth test I was writing, it immediately passed as soon as I wrote it. And I paused and looked at my fellow developer and said, hey, I don't know about you, but I'm never that good. Do you think this is so awesome that every test I'm writing is actually passing? And my pair looked at me and said, no, I'm not that good either. So we both really broke the code in front of us, and the test was still passing. That was a sign that it was not actually running our test. So you want to make sure the test is actually running before you enjoy the feedback loop is working. So I'm going to change it to a false right there and hit the save. That's all I did. And you can see the red color output that tells us the test did not work properly. And then it's, of course, giving you an error right there. And then I'm going to change it back to a true and save it. And you can see that actually passed. So that gives you a feedback that the canary test is running. The tool is set up properly. The environment is set up properly. A real quick detour before we go further. Not only am I a big fan of writing automated tests, I truly believe in getting continuous feedback loop as well. So right about this time, I often tell my clients, if you have one test passing, like a canary test, for example, this is a great time to stop writing more tests and immediately throw this code into continuous integration. So set up your continuous integration server, whatever that could be, Jenkins or other tools you use. And typically in my Jenkins, I'm not a big fan of wasting or spending a lot of time on configurations. So typically my Jenkins would fire off a batch file, and the batch file will do npm install and npm test with a coverage on it. So this is the time I would normally set up the continuous integration. So every single line of code I check in immediately gives me a feedback that the code is actually working. Not only that, sometimes people ask me, when do you normally do this? What if you're working on a small project? And I'll tell you an example of a small project. I'm the only developer on a project, and I wrote this code about 6 or 7 years ago, but it gave me sleepless nights because my code is talking to a credit card processing server. And what if the credit card processing server is broke? What if they change the API on me and they don't tell me or I don't take note of it? This freaks me out. I'm not kidding. What I have on my server is that every 15 minutes, the process wakes up, the CI build wakes up and runs through all my tests, both my integration test and my automated unit test. And so it hits the credit card engine and makes sure that the API is still working properly, and I'm able to go through transactions and the failures and the success are working properly. And in the 6 or 7 years it's been running in the CI, every 15 minutes it runs, and if it were to fail, it would send immediately a text to my phone saying that something is wrong. About 3 or 4 months ago, after being quiet for so many years, I was in a conference giving a talk, and it just pinged me saying, your build is broken. I kind of freaked out in the middle of my talk. I couldn't focus on the talk anymore because I'm like, what happened? Well, then after the talk, I rushed over, take a look at it, and realized that they had actually changed one of the test data on their test server, and that was causing the failure. And in a matter of hours, they put it back and everything worked. This gave me feedback on 2 things. One, what I set up actually works, and then of course I can have a more peaceful sleep in the night knowing the code actually works. And I truly believe in that kind of feedback loop to know that things are actually working. Well, now let's take another trivial little example to write over here. I'm going to just take a silly example of dividing a number. So I'm going to say divide, let's say 6 by 2, should give 3. And again, how do I write a test for this? I'm going to say expect, in this case, divide, and I'm going to say 6 over 2. And then, of course, I want this to be equal to, let's say a value of 3. That's the response I want from this particular request. And you can see that test actually failed, obviously, because I don't have the divide function given to me. So what am I going to do? I'm going to edit the source directory and a sample.js. And in this case, of course, I'm going to say function, let's call it divide, and let's go ahead and say this is operand 1, operand 2. And all I'm going to do is simply return the value of 3 to make the test to pass. And you can see that actually worked. A tenet of TDD, you lie your way through before writing any useful code. Then the next thing I'm going to do is to say divide, let's say in this case 8 with a 4. Well, in this case, of course, you want the result to be a 2. And I can make sure that part is working as well, just to see if that code is being exercised a couple of different times. And then, of course, when I execute the code, you can see the test is failing. Going back to the code, I can say this is op1 over op2. And of course, the test should bounce back to passing. It did. One other thing I want to quickly mention before we go any further. So there are 4 types of tests that I typically like to write when I do automated testing. The first type of test is called a positive test. A positive test simply tells me the code did what it's supposed to do. And a positive test is a quick feedback that the code is working as intended as change happens in the future. Well, the second type of tests are called negative tests. This is to verify the code is dealing with the invariants properly. As an example, I once had a mortgage with a bank, and I refinanced the mortgage, so it was moved to another bank. And 2 months later, we figured out money was missing from my account. And then eventually we traced it back to the bank was putting money into a closed mortgage account. Well, clearly somebody did not write a test for the invariant that you cannot put money into a closed account. So that's an example of how you can see these things happen in banks and airlines and other places where things are broken. In fact, I'm dealing with one problem this morning with the airline because something is broken in my account because of 2 transactions I did last night. And of course, clearly somebody did not do the testing properly. That's costing a lot of time and money as well for everybody involved, customers versus the developers of the organization as well. The third thing I really like to see is called exception test. Exception tests are to really tell us that the code is throwing the right kinds of exceptions that it's supposed to throw, and you want to make sure that as code is evolved, it is throwing the right kinds of exceptions. And the last thing I want to emphasize is called a performance test. And I often tell, if performance is really important, don't talk about it, write a test for it. And the reason I emphasize writing a test for performance is you want to make sure that as the code evolves, your code does not go into a situation where it's no longer meeting the performance, a regression has happened. A case in point, a client of mine said performance is extremely important, and they did a lot of work to improve performance, but forgot to write a test for it. About a year later, they were dealing with the same problem again, and they found out this problem was a regression nearly 7 months earlier. and you had all this time to fix it, but there was no feedback loop to tell you that there was a problem. So I always say, if performance is really important, write a performance test and then improve the performance, and then have a feedback that it's actually working moving forward. Well, here, of course, I want to write an exception test. So I'm going to say divide by 0, let's say throws exception. So what do I want to say here? I want to say expect in this case, and I'm just going to copy this code for a second over here. So expect. But what do I want to expect from this code? I want to divide, let's say, 8 with a 0. But if I divide this, what do I want this code to do? Well, I want this to blow up on my face and tell me there's an exception. But there is a problem though. If you notice over in this code, you know as a programmer using JavaScript that this divide will be called first, and the result of divide is sent to expect. Well, that's too late, because if divide blows up, there's no expect to be called. So what do? Well, use a level of indirection and say, don't call divide now, call divide after you call expect. So expect is called first, and expect will call divide now, not you directly. So you're putting a little arrow function to say, don't call divide right now in this test, first call expect, and within the expect call the divide. Well, what should it do at that point? And you can say to throw, and I want an error that it's throwing at that point. So this tells us that when you call divide, it better throw an exception, and that's a way for you to write an exception test. Clearly, in this case, when you run this little code, it's going to tell you whether it is throwing the exception as you expect, or it doesn't, and it's going to blow up the test itself. So the failure of the test is the failure of the code to throw the exception, and the success of the test is the exception in the code itself. Clearly, you can see the test actually failed, and the reason is because the code is returning an infinity rather than throwing an exception. Well, clearly you can find different ways to solve this problem, but for now I'm going to simply say is equal to, and I'm going to say 0, then I'll simply say throw new error, and then we'll simply say divide, let's say by 0, and I can blow up at that particular point to say that's what the exception is, and the test is passing. Now, while we are at it, one of the things I often say is, while we can get this kind of feedback, I'm also a big fan of keeping an eye on code coverage. Now, a lot of people don't like code coverage, but I love it. The reason is every time somebody points me to code coverage, we focus on the design concern rather than the coverage at that point. So this has been a rewarding experience for me. So when a programmer comes to me and says, hey, this code has a poor coverage, what do I do? We're not talking about coverage anymore. We discover a design problem in that code and we fix it, and the coverage automatically becomes better. But just to illustrate the point, suppose I'm sneaking around and putting op1 is equal to 1000. I'm going to simply go ahead and put a little code here. Let's say oops. So if I sneak in code, and we all do, you can see the code passed the test, but I'm very curious, what do I know about it? Well, I'm going to go ahead and quickly look at something here. Let's go ahead and edit the karmaconf.js file really quickly. Let's go to the preprocessor over here. And in the preprocessor section, what I want to do here is to say, look in the source directory, the subdirectories, and all the JavaScript files, and then go do a coverage on that. And then I'm going to go to the reporters that you see below, and I'm going to ask for a coverage on that as well. So I just introduced a coverage for all the files in the source directory, and then I asked for a coverage reporter as well to be brought in at this point in the karma.conf.js file. I got to do 2 more changes before we go further. I'm going to do npm install, and this is going to be karma coverage, and I'm going to then ask it to save dev as well on that one. While that's doing it, let's go back to our package.json file, and in the package.json file, I'm going to do one more thing, which is to bring in the coverage as well, so we can actually look at the coverage report when this is running. So let's go ahead and karma coverage. It helps to really spell it properly. So let's go ahead and try that coverage. So go ahead and install that. And then, of course, when it's done, we will simply run the coverage and see how it works. How do I run the coverage? Oh, nothing really different. npm test. Or if you don't want to do that, because I want to run in a manual mode versus automated mode, and I want really coverage to be done on my automation server without running it repeatedly. So typically, I would set up a test for running locally and a coverage for running on the CI machine. And on the CI machine, I will run the coverage rather than running the test. Locally, I will run the test rather than running coverage, or back and forth. We can do that. So let's go back and run the test and see what it tells us. It fires up the browser again, and then of course it says success. While it's showing that, look at the coverage directory right now. Based on the browser that you are using, it gives us the index.html file. Let's go ahead and open that file really quickly here to see what it tells us. And then you can see that in this particular file, it contains the coverage report for that little file we wrote, and of course busted, that little code I wrote with no test at all shows up in red. So this can be really a nice way to get the feedback loop that the code is being tested, and we can know that the developers are doing automated testing. In that regard, I use a very simple rule for my developers. I tell them you got 3 choices to really get good unit testing. 1, do it, right? So just go ahead and do it, and don't give excuses, do it. Well, if you cannot do it, step number 2, ask for help. And come by and say, hey, you know what, I'm writing this test, my coverage is really poor, help me. If you don't do step 1 and 2, there's a third option, be yelled at. So this is basically a very simple rule I follow. If you don't do it, ask for help. If you don't do it and don't ask for help, be ready to be yelled at. And so essentially, you want really people to work on solving problems together, not hide away and give excuses. And I may not be the smartest person in the team. I don't know how to do it. Maybe you don't know how to do it, but we both can collectively figure out or find a third person to help us, and that's extremely important. The last thing I want to mention really quickly here is we saw how to write tests and how to get feedback loops. We saw how to do all of this, so we covered up to this point already. But there's one thing we have to still deal with in our lives, which is dependencies. And dependencies often are really gnarly. One of the biggest problems generally in automated testing is very easy when the code you are testing is very predictable. In other words, if a code is idempotent, it's easy to write tests on it. When was the last time a dependency was idempotent? Almost never. Dependencies give us different responses every time we call it. So when a dependency is not idempotent, testing the code that works with the dependency becomes incredibly difficult. So what do? All this idea about mocking and stubbing is simply to take an unpredictable dependency and replace it with an idempotent mock, so we can really get a fast feedback loop on the code we are writing. So how do we write an automated test for that? Well, the short answer is one of the best tools I've ever seen in the market, and that is called Sinon. And Sinon is just amazing in my opinion. Sinon is wonderful in terms of how it can give us a really good fast feedback loop. I want to quickly show you an example of using Sinon. I've already installed Sinon right here. As you can see, it's in my dependency. So what am I going to do? The first thing I'm going to do is to create a source, weather.js. So my weather.js contains a function called temperature, and given a city, it is going to return the temperature for that city. So I'm going to say throw new error, not implemented yet. Obviously, I don't want to implement that now, because implementing that now it's not going to help, because the temperature is different every time you query for it. But I want to know what to do based on the temperature in a city. I want to work with the temperature. What am I going to do? So to answer that question, the first thing I'm going to do here is to go to my test. In my test, I'm going to say sandbox is a variable, and I'm going to create a before each. And in the before each function, I'm going to create a little sandbox in this case. So function, what do I want to do here? Sandbox is equal to Sinon.create sandbox. So I'm asking it to create a sandbox. You never want to talk to Sinon directly, because it's an extremely powerful tool. If you tell Sinon, hey, you see that function over there? And Sinon will say, no worries, I destroyed it, create a mock for you. And then you're like, thanks, Sinon. Now that you're done with it, I'm done with the test, put it back together. It says, what do you mean? So it doesn't know to put things back together. So never use Sinon directly, put it in a sandbox. So what can you do? In the after each function, you can simply now say, here's the function, and I can say in this case sandbox.restore, and this is going to blow away your changes and restore for the next test. You want the test to be isolated and independent of each other. So now that we created a Sinon, what am I going to do next over here? Well, the next thing, of course, is, oh, it's giving us an error. Let's take a look at what it is. So after each is giving us a little problem here. Sandbox, let's make sure that we got this correct here. So I got a sandbox set up right here, the sandbox, and I'm going to restore the sandbox, and this is going to be create a sandbox. So let's make sure that I got this right. Let's take a look at the error itself. What does it say? It says that it cannot read property restore of undefined. Well, did I make a mistake? Anybody sees the mistake? So before each is being run here in the test, and this is going to tell us that sandbox is going to be Sinon.create sandbox. So that should have created the variable up here, and then I'm asking it to destroy it right here. Anyway, I'll come back to that a little later. So what do I want to do next? Now that we have a sandbox being created, my next step, of course, is to, there's an error in the before each as well. So let's see what that's complaining about. Maybe it's, oh yes, okay, let's do something else. Edit karma.config.js. Good. So what do I do here? I want to bring in Sinon to the party, right? So we didn't invite Sinon, so it was very unhappy with us. So right there, we brought in Sinon as a plugin. Let's go ahead and fire this up again this time, but I'll bring in the after each again. Let's run that and see that it's actually firing up the browser again, running the test. It's happy. Great. Now what's the next thing I want to do? I want to give a recommendation on where, let's say, wear t-shirt, let's say for warm weather. So for a warm weather, I want to wear a t-shirt. How do I do this? So I'm going to say expect, and I'm going to say wear, and then for a visit to Tampa, let's say next week, and what do I wear for that? To be equal to, I want to wear a t-shirt. Now the question is, how do I know what I should wear to Tampa next week? Oh, the weather is going to be really warm over there. You should take a t-shirt. But how do I know? Well, the answer to that is I'm going to go here to a function called where, and I'm going to say a city over here. But what am I going to do within this code? I'm going to find the temperature in Tampa and decide what to wear based on it. Oh dear, I can't tell what this code is going to do because the weather keeps fluctuating. I can't make a recommendation all the time. So what am I going to do? I'm going to go to the sandbox and say sandbox stub on the window object. Go ahead and stub the temperature object, so temperature. And what am I expecting? When it's called with arguments, so with args, and what's the argument I'm expecting? Tampa, obviously. Then what should I do? It should return to you a value of, let's say, 80 degrees. So that's a beautiful temperature in Tampa, and it returns 80 degrees. Now, of course, when I save this code, the test is failing. But if I go back over here and say if, let's say for constant temperature, let's say temp is equal to temperature of the city, and then I'm going to say if the temperature is greater than, let's say 75, then return a t-shirt as the one that I want to wear. So I can go ahead and save that and see what it wants to return at this point. So constant temperature equal to, temp is equal to temperature. And then of course that can come from the city. I'm going to just restart this really quickly. And then of course at this point I'm going to say when that is executed, if the temperature that you are getting is greater than 75, then return a t-shirt as a response back to me. And then over here I can say expect where, which is the function that I'm going to write over here, pass the city Tampa over here, and then of course it better be equal to a t-shirt as a returned value. Let's take a look at what the error message says over here. It says returns is not defined. So this is going to be a dot that's missing. So let's go ahead and put the dot in there, and you can see the test is passing. So you can see how, just to illustrate the point, if I remove this stub right here, you can see the test is failing with the not implemented yet exception. Obviously the function is not implemented, but this is hijacking that particular function and reworking it. And just to illustrate the point with one more test, where maybe a sweater, let's say sweater, and let's say for cooler weather. And what can I say? Let's go ahead and change the city over here, and we'll say, give a different name. Let's say this is going to be a 50 degrees. Okay, we better really wear a sweater. So I can go ahead and say this is going to be a sweater weather. So that test is failing, as you can see. I can come in here and say, if the temperature is greater than or equal to 50, maybe I can say return a sweater, which is what I want to return from here, and that gives you an idea. So I use Sinon pretty much to mark away my dependencies on my servers. So I don't have to have my server running. I can get my full feedback on my client side without even bringing it up the server and without having to run the HTML through that. So I get a fairly good feedback loop along with this. So hopefully that gives you an idea about what we can do with these kinds of automated testing. If you're interested further, check out my website. There's a downloads link. If you don't find stuff you're looking for, drop me an email. I'll be more than happy to hear from you. Hope that was useful. Thank you.